Hello everyone, I welcome you all to yet another session on numbers topic. So this is the 7th session in line. Right? So today we shall be talking about the different LCM model problems that we have. Right? There are 3 models to be precise. We shall be talking about them here, maybe 2 of them here. Third model we'll try to take it in the next class. But before I proceed with the lecture today, I would just like to remind you all that we also run a video series involving CAT level questions. Please do also watch them out, right? See, I am sure that even those question videos would be of help for people who are preparing for CAT and other such examinations. So please do subscribe to our channel and also hit the bell icon so that you are notified every time we release a new video. And we will be doing it almost on regular basis. Every day, every second day, we will be releasing a new video. So let's get started. So when I say LCM model problems, so basically the question types here would be involving the application of the LCM, least common multiple concept. Let's start off with an example. So if I say find, just a minute. So if I say find the least 4-digit number that leaves remainder of 3 when divided by 7, 5 and 6. In each case, it leaves a remainder of 3. So, to find the least 4-digit number which satisfies this condition, right? Which satisfies this condition. Now, what I would suggest is you please pause the video at this moment and try out this problem by yourself, alright? See what's the answer that you get, and then you can just verify with the answer that we shall be getting out here in this video. In this particular question, I would be solving it as I said. However, I'll be solving it. Let's get started with it. So I'll not be using any formula or anything for now. I'll solve it by the regular approach, and then right after that I'll share the formula and describe what that formula gives us. Right. By the way, this problem type is called as LCM model 1. I'll explain LCM model 1 sometime, but let's solve it without any additional knowledge based on only what we have discussed so far in the previous classes. So let's say the number that we are looking for is n. So n is something that n is the value that we are supposed to find out. N is the least 4-digit number that satisfies this condition. So what's the condition? So when you divide n by 7, 5 and 6, the remainders are 3 in each case. 3 in each case. So when n is divided by 7, the remainder is 3, n divided by 5, remainder is 3, likewise n divided by 6 also, remainder is 3. Now, before I move to the next step, there is a small point I would like to cover here. Please note, if you divide any number, say 17 by 7, so we know that the remainder is going to be 3, right? Manually you can check that, it's 3. So 17 divided by 7 gives you 3 remainder. That would mean 17 minus 3. So if you remove this remainder part from the dividend, 17 minus 3, which is 14, can I say it will be divisible by 7? So if n divided by d gives you r remainder, so can I say n minus r is going to be a multiple of d or not? There is also visually, we can actually look at it from division rule also. Observe this. Dividend is equal to divisor into quotient plus remainder, we say, right? So if you take this plus r on the other side, you get n minus r is equal to d into q. So that means, can I say the number n minus r will be a multiple of the divisor only? We can say that. I hope that point is clear. So I'll try to make use of that point and say, let me just clean this. So and then I'll say n divided by 7, remainder is 3. That would mean n minus 3, can I say, must be multiple of 7. Similarly, n divided by 5 gives you 3 remainder. That would mean n minus 3, the same number, must be multiple of 5 also. Similarly, n minus 3 must be multiple of 6 also. So, combining that, can I say, since n minus 3 is a multiple of 7, multiple of 5, multiple of 6 also, so can I say n minus 3 should be a common multiple of these 3? So, can I write, how do we write the common multiple? So, n minus 3 will be equal to their LCM into k, because please note, I do not want the least common multiple. Had I wanted least common multiple, I would put k as 1, but I want just common multiple, so I can put k as 2 also, k as 10 also, k as some other value also, thus I put k there. So, k into LCM of these. Now, what is LCM of these 3 numbers? Please note. So, LCM is nothing but 35, 210. 210 into k. So, n will be what? 210 into k plus 3. So, my number should be of this form, we say. Now, next point. I want the number to be smallest 4-digit number. So, let's try to do some calculations now, mental calculations. So, for what value of k will this number n become a 4-digit number? Let's check. So, if I put k as 2, it's 420 plus 3, 423. No, it's not. K as 4, 840 plus 3, 843. No. K as 5, yes, it will be 1050 plus 3. So, thus can I say the least value of n, 4-digit number, least value is going to be 1053. So, this is how we can figure out the answer without using any formula as such. However, the same problem can be answered by using a formula. Let me just share that formula. This is called as LCM model 1. The property is, if you have a number n, which when divided by p, q and r, there could be more than 3 divisors also, leave remainders of a and a, common remainder, same remainder. See, this is the identification for model 1. So, how do I identify whether a problem is model 1 or not? Simple, you please look at whether the remainders are equal or not. If the remainders are equal, then it's model 1, otherwise it's not. So, divisor PQR gives you remainder a and a, then in that case, the number n can be written as, the formula is k into LCM of divisors plus the common remainder a. So, this equation will directly give us the value of n, the general value of n, and depending on the problem, you want the largest 3-digit number, smallest 4-digit number, largest 4-digit, whatever you want, you can figure that out by putting in a relevant value, appropriate value for k. So, this is the formula that we have for finding out the number. So, if you look at the expression, is this not equal to this? Please note. So, what did we write here? K into 210. What was 210? LCM of the divisors plus the common remainder 3. So, this is the basic process and this is the direct formula. So, this is your LCM model 1. Now, if you know this model, please see, if you have a question of the following type now, find the largest 3-digit number which leaves remainder of 7 when divided by 12, 18 and let's take 15. It leaves remainder of 7 in each case. So, it's a LCM model 1 problem, clear, right? So, how do we answer it? So, my answer directly will be n will be equal to k into LCM of the divisors, right, plus the common remainder which is 7. Now, by the way, what is LCM of these 3? Please note. So, it's going to be what? I think 180 will be okay, 180k plus 7. I want the largest 3-digit number. So, I need to put appropriate value for k. Let's check what do we do. K equal to 4, 720 plus 7, 727. I think there is still some leeway to go forward. There is some more headroom that we have here. Let's try to put k equal to 5. 900 plus 7, 907. Very, very close. k equal to 6, 180 into 6 is 1080, it will become a 4-digit number. Hence, can I say I can only put k as 5, and hence my answer is going to be 907. So 907 is going to be the largest 3-digit number which satisfies the given conditions. So this is your model 1 problem. So just to recap, model 1, the identifier is, how do I identify whether the problem is on model 1 or model 2? Model 1 identifier is common remainders. It should be same remainder. So this is your LCM model 1, this was your LCM model 1. Now let's move on to model 2, LCM model 2. Now for LCM model 2, let's take up an example. Find the least 4-digit number which when divided by 7, 11 and let's say 7, 11 and 8 leaves remainders of 2, 6 and 3 respectively. So clearly one thing is certain here, this is not model 1 clearly, because there is no equal remainders that we have. It is not model 1, but it is model 2. Now how do I identify its model 2? Let us try to understand that. But again, before I give you the formula and all, I would like to just explain the process first and then I try to give you the formula also. So let us say the number that we are looking for is n. So when n is divided by 7, 11 and 8, the remainders are 2, 6 and 3. Now right now it appears to be a problem involving different remainders, but there is a small process that we could perform and change the entire thing here. Observe, in the previous classes we have seen the concept of negative remainders, right? So for our convenience only, we never answer it as negative in the exam, but for our convenience we can try to convert a positive remainder to negative remainder. Alright, we can do that. So here for example, when you are dividing any number by 7, if the positive remainder is 2, what will be the corresponding negative remainder? So can I say it will be 2 minus 7, which is minus 5. It's going to be minus 5. Similarly here, when divided by 11, the remainder is 6, positive remainder. So can I say the negative remainder will be 6 minus 11, which is minus 5 again. Here also, positive remainder is 3. So what's going to be negative remainder? It's going to be 3 minus 8, which is going to be minus 5 yet again. So what I notice here is, even though the original problem had different remainders, when you look at the remainders in terms of positive remainders, but the moment you convert them into negative remainders, the remainders are turning out to be equal. Now can I say this problem out here is actually model 1 problem in disguise? It's not straight away a model 1 problem, but when you do the small operation of converting positive remainders to negative remainders, you can observe that it's actually a model 1 problem. So thus model 2 identifier could be, model 1 identifier was common remainder, positive remainders. Model 2 identifier would be common remainders but negative remainders. So negative remainders when they are equal, then it is model 2. So this is converted into a model 1 problem, right? So how do we write the value of n here? So the value of n will be equal to, I am using the model 1 formula, which was this, k into LCM of the divisors plus common remainder, which is minus 5, not 2 or 6 or 3, we will write minus 5 here. How much is this? This is 56, 7 and 8, the LCM is 56, 56 and 11 will be 616, okay, minus 5. So this is the number type, and what do we want? N to be least 4-digit number. So least 4-digit, again if you will just observe, you can easily make out, if I put k equal to 2, I will get the 4-digit number, the smallest. So thus k equal to 2 would mean 1232 minus 5, 1227, sorry. 12, 27. So 1227 is going to be the smallest 4-digit number which is going to satisfy this condition. Please appreciate the fact that now that we have access to some methods, we can actually figure out any number that we want to. For example, had the question been largest 4-digit number, even that problem can be figured out. However, it will take more time, but we can still solve it. There is no scope for going for hit and trials here. So for example, I'll go for some random number like 1200 and check, 1201 and check. No, that's not possible. You cannot solve it like that. You need to get down to a fixed answer, and this would be the way for it. I hope this was clear. So this is your model 2 problem and one example associated with it. Now we have a model 3 also, right? We have a model 3 problem also, which I would like to cover in our subsequent class, right? I'll try to cover it in the next video, right? Here in the remaining time, I would like to just share a small point about LCM and HCF, particularly LCM. Look at the following question, please. If it is given, I am going to share a small trick, a small formula. If it is given LCM of 2 numbers is, let's say, 50. The question is, find number of possible values for A comma B. What will be the number of possible values for A comma B? So again, if you try to go for hit and trial, maybe you will get to the answer, or most likely you will not get to the answer. You will be somewhere near, right? Maybe you will miss out some cases, etc. So in order to answer such questions, we have a simple formula. The formula is as follows. Look at this. First thing is, you prime factorize 50. So what is the prime factorization? 2 into 5 square. 2 into 5 square. The formula is this: if LCM of A comma B is equal to A to the power alpha 1, B to the power alpha 2, C to the power alpha 3, where A, B, C are prime numbers, suppose, then number of possible values for A comma B will be equal to, you look at the power alpha 1, you take twice of that plus 1. Power alpha 2, twice of that plus 1. Similarly, plus 1. That is how you get to the answer. That is the trick, that is the formula. I will try to explain the logic also while I am solving it this way. Why does the formula work? Observe. Now when I am trying to look for a LCM, so that means the value on the left hand side, LCM, must have a multiple of 2. And what multiple of 2? At least 2 power 1. Okay. When I say common multiple, it could be 2 power 2 also, 2 power 3 also, but since it is least, it should be 2 power 1 only. Now how do I get 2 power 1 from A and B? So either the 2 power 1 may be there in B, not in A. Either it is in A, not in B, or it is there in both A and B. So that means this power of 2 power 1, the 2 power 1 value, can be distributed over A and B in 3 ways, correct? So this could be distributed in 3 ways. I hope you see that. Next, observe, if I look at 5 power 2, how can I distribute 5 power 2? It could be like A has no 5, B has 2 5s. Or A has 1 5, B has 2 5s. Or A has 2 5s, B also has 2 5s. Or the reverse of this, A has 2, B has 1. Or the reverse of this, A has 2 and B has none. So that means this value of 5 square can be distributed over A and B, can I say, in 5 ways? And hence overall my answer, this 2 power 1 can be distributed in 3 ways, 5 square can be distributed in 5 ways, my answer will be 3 into 5, 15 ways, or A and B have, A comma B have 15 different solutions. Let us apply the formula also and check. So if I apply the formula now, if I apply the formula and try to answer, alpha 1 is 1. So what is 2 alpha 1 plus 1? Alpha 2 is 2. So 2 alpha 2 plus 1. So what is this going to be? This is 3. This is 5. My answer is going to be 15. the same answer. So, that is the formula and this is the logic behind the formula. Okay, how many ways can you distribute 2 power 1? 3 ways. 5 square, likewise 5 ways. I hope this formula and this problem is also clear to us. So, now even if you have 500, I am sure you can manage that. So, with this we have come to the end of the lecture today, right. So, as I said, there is one more model left of LCM and a couple of models of HCF which we will cover in the next video. So, till then, thank you, right. Please do subscribe, right, to get access to other videos that you have, or otherwise just watch them and see how helpful they would be. Thank you and all the very best.